Hi, everybody. Thanks for joining. My name is Cindy Renier. I'm with Berkeley Lab as well. Today's top session is going to be on connected communities. I think you've heard a little bit about grid interactive efficient buildings quite a bit so far, and demand flexibility. Connected communities takes that a step further, that concept, into a grander scale. The way we define a connected community is important for this discussion. And generally speaking, it is a group of grid interactive efficient buildings, the types of buildings that you've been hearing about so far. The concept is that these are buildings that are energy efficient to start off with. Efficiency is not going away. It's still a key resource for carbon reduction. But we also are interested in integrating DERs and load flexibility, whether that's through flexible HVAC, water heating, lighting, or through batteries, photovoltaics, and electric vehicle charging. And then uniquely to connected communities, we're really trying to coordinate controls across multiple buildings so that in aggregate, we are trying to provide a reliable resource for a utility to rely on to be able to change how they operate the grid and really maximize the use of efficient and renewable energy supply. So overall, the goals are to both lower energy use and energy cost at the building scale, but in a way that supports the grid to really maximize the use of these efficient renewables that are coming online. And underscoring all of this, we are definitely paying attention to the occupant, making sure that comfort and needs are being met. So Connected Communities is a DOE-funded program that is $61 million and had selected 10 projects or leads, if you will, across the US. And intentionally, these projects were chosen with geographic diversity, climate diversity in mind, but also in terms of the utility conditions, because we recognize that there are going to be different grid issues and grid needs depending upon what the fuel supply mix looks like, and what the climate impact is, both on the building scale and for the grid. We also have a wide variety of types of projects. I'll speak to that on the next slide in a minute, but these are 5-year projects and they're in about year 2 currently. So we're early on in the demonstrations, but already have quite a bit to share. So in general, these demonstrations are really interested in trying to understand performance. So, how are the projects able to provide reliable grid services? So there's a technical component to the projects that we're very interested in understanding. But we also recognize that in order to have this make an impact at scale, we really need to understand the value proposition, not just for the utility, because there's clearly some benefit to the utility, but also how do we develop value streams so that building owners and customers will want this? How can they get incentivized, either through rates or incentives from the utility to engage in these types of controls? But also, what's the value proposition for the utility? What's the value to them in their grid? And for a third-party aggregator, how can they make a viable business model out of this? So we're really interested in the business aspects of this, not just the technical performance. And underlying all of this, we do seek to understand technically how do these solutions get implemented and applied, not just at the building scale, but with this additional controls layer for coordinating across the different projects. So Berkeley Lab is in a unique position in this program. We are in a role called National Coordinator. So we're not participating in the individual demonstration projects, but we are providing some broad program technical assistance and support to help with an eye towards understanding how do we scale these projects for impact in a grander way. So our role is first to provide technical assistance, whether through sharing tools and resources with the awardees, and to understand, what gaps and needs they have in designing these types of approaches and implementing them, to identify, do we need additional resources or tools to enable industry to scale these methods. We also convene the cohort of awarded projects to learn in a peer-to-peer exchange. And as National Coordinator, we also are in a strong role to develop the evaluation methods that are going to be implemented across the individual projects. But also we're here to do cross-cutting analysis across the entire cohort of projects to understand best practices, lessons learned, what technologies and control mixes provided the best grid services reliably, and so on. But we're also going to be evaluating along other vectors that I mentioned earlier, the business model, value proposition side, and so on. With the cross-cutting analysis that we'll be doing as well, we'll be documenting and sharing best practices, not just from a technical approach, but all the other ones that I mentioned too. So the 10 awarded projects are illustrated in this slide. I'm not going to go through this in great detail, but you'll notice that all of them have an efficiency goal. So efficiency is not going away. It absolutely is the first least cost step that we should have in addressing decarbonization. The projects are a mix of new construction and existing buildings. We really wanted to show that there are technical approaches that are viable for a wide range of building types and vintages. So you'll see everything from single family residential to multifamily. There's a strong low and median income affordable housing component to some of the projects. We also have commercial properties represented, both publicly owned commercial buildings as well as privately held ones. What else is there to say about this? Generally speaking, the numbers of buildings involved are high, unless they happen to be for a relatively high energy use complex, such as we have one campus project represented in the mix at the bottom there. It's the Ohio State University, which is demonstrating how a portfolio of buildings, a common portfolio owner could implement a similar strategy for their mix of buildings. But we do in some cases have other just commercial building projects, such as the one with Slipstream, which is working in the Madison, Wisconsin region. On the far right, you can see what distributed energy resources are involved in the different projects, the PV, batteries, electric vehicle charging, and so on. In addition, not represented here are the other load flexible technologies. HVAC is strongly represented here, including some retrofits with heat pump technologies. We also have a lot in the way of water heating, occasionally lighting as well, for a variety of different grid service types. So now I'm going to go through a couple of projects in a little bit more detail to kind of give you a better flavor of the types of technical approaches that are involved here, and really some of the context for why connected communities is going to be a strong value proposition for some utilities. EPRI happens to be having two neighborhood communities that they're organizing and running. One is in the Seattle area and the other is in New York City. They're being managed as separate neighborhood projects for their particular regions. Both, though, are very focused on affordable housing and low and medium income multifamily communities. So this is often with like a community housing developer involved, or in the case of New York City Housing Authority. And there's often a tenant model. So you have that split incentive issue to be concerned with. And really interesting, both sets of communities are really focused on decarbonization with retrofits of shifting away from fossil fuel-based heating into heat pump technologies. And a real risk with the LMI community is that you can end up with higher energy costs and utility bills. So a goal of this project is to demonstrate how doing this community-based approach, providing grid services and getting additional money for managing the load better, is to reduce the energy burden on the tenants. So energy cost reduction is definitely a strong aspect of this work. Notably, though, in terms of the utilities benefit here, on the Seattle side, the buildings that are being targeted happen to be located strategically on a distribution feeder that is capacity constrained. So with electrification, the load's going to be growing on that feeder, and it's already at a level that would require infrastructure upgrade, very costly infrastructure upgrade, transformers and feeders and so on. And the project is trying to demonstrate how load flexibility coordinated with a number of buildings can defer capital investment and upgrade of that distribution feeder. So there can be a very strong utility incentive for capital upgrade deferral if we're successful in showing how the demand flexibility can be relied upon at a grander scale to help manage the load. So there's other grid services that these projects are trying to manage as well. I just mentioned a couple of the more, strongest value ones, but in general, all these projects are trying to address and provide multiple grid services. Sometimes shed, sometimes shift, other times they're implementing sometimes frequency regulation or voltage regulation as well. So the key innovations here are really showing affordable building retrofit decarbonization pathways. In the New York case, they're piloting 120-volt heat pump water heater deployment. There's also some novel window unit replacement. Window units are common in New York City, or can be in the low and medium income for air conditioning purposes. But if we can do through the wall heat pumps, that can be an effective way to decarbonize and in a way that kind of works with the current constraints physically in the space. There's some other aspects to this project that are listed here. I won't go into great detail, but just know that in general, they're always trying to do more. In this case, they have some resilience benefits they're trying to implement as well, using bidirectional electric vehicle charging to help provide power to the building if the building is without grid-tied power during a power outage. I'll move on to the next example, which is with Slipstream. And this is actually a two-phase project in the Madison, Wisconsin area, working with Madison Gas and Electric. In the first phase, they're starting with a pilot that is with municipal-owned buildings only, and there are a range of different commercial buildings spanning office. I think there's a fire station in the mix as well. So it's, generally speaking, regular commercial offices. And they're deploying a range of different load flexibility there, and the results of that pilot are going to inform what packages of technologies, load flexible technologies and DERs, get then piloted into a program, a utility-based incentive program into privately owned buildings that Madison Gas and Electric will be using. Notably, a strong outcome for this project is that they're trying to develop a scalable business model for utilities to bundle demand responsive technologies together with energy efficiency incentive program rebates. So typically, demand response programs and efficiency programs live in silos and they don't well coordinate. But Madison Gas and Electric is trying to develop a turnkey approach where both can exist within their new pilot program. Otherwise, it's worth saying throughout all of these projects, they're generally using commercially available off-the-shelf proven technologies. They're typically not using very innovative bleeding edge technologies. The innovation and the level of effort is really on the control side. How do you connect these flexible end use devices in a way that can coordinate and provide this reliable grid service at some scale? And I'll talk a little bit more about that, but that's really where the innovation is. It's where the work is the additional customization is needed to be done, and where we need a strong workforce to help transition these types of projects into a grander scalable reality. Another outcome of this project is really looking at a toolkit approach where financing options will be available to help support the installation of these demand flexible technologies. Moving on to our next example, I tried to show a mix of different, residential, commercial, and a little bit of industrial in here too. This is Rocky Mountain Power. This is a project that's being developed in the state of Utah. And the community in this case is a downtown urban environment where they're targeting a mix of apartment buildings, mixed use retail, university laboratory, and also manufacturing building and single family residential. So it's all of the above approach. The project is really trying to provide grid services to the wholesale market. And so some projects are very focused on providing value and benefit to utility at the distribution scale. And in other cases, it's at a much higher scale. So at the wholesale or even transmission and distribution level. And there are different financial mechanisms that can come into play when you participate in that market. A novel thing with this project is that they are trying to, from the utility side, use distributed energy resources as a key resource in their planning of their grid. Typically speaking, they aren't creating pathways that really rely on demand flexibility through DERs into their future forecasts for how they're going to provide and support their customer base with power. But that's called an integrated resource planning effort. But this will be one of the first of the kind that is actually trying to fold in this demand flexibility into that process. My next project is really focused on residential with about 500 new construction, 500 existing single-family, multifamily. Many of the typical of the grid services that are at play here are similar to some of the ones that we talked about before. In general, reducing utility peak capacity is a strong element here. This is being deployed in North Carolina and Duke Energy territory. And a novel thing that's happening here is with decarbonization efforts and electrification of heating, many of the utilities in this part of the United States are going to start to see that winter peaking will start to be a reality for utilities that have historically had much more in the realm of summer peak being the condition. And in the colder climates in particular, you may end up with electric resistance as backup heating and for the coldest parts of the winter. And that will really impact the potential grid of the future, which will be capacity constrained for that condition. So Ibicos is working with Duke Energy and their project team to really demonstrate how demand flexibility can be viable for those types of HVAC retrofits with the backup electric resistance heating, and in a way to defer utility capital investments. So that's another strong aspect of this work. I wanted to just step back a minute, though, and really talk about how these projects are being implemented and where the novel applications really are occurring. And really, this occurs with the controls architecture and how it's being applied. They all start at the site level with demand flexible loads, but how those get integrated and receive signals from the utility is different. And we've come up with about 3 different archetypes that illustrate different approaches with where the market currently is at and how they're doing this. We do expect that this model will shift over time as grids become much more saturated with renewable energy, and they'll be required to do much more in the way of more discrete management of flexible devices. But currently there are about 3 different approaches here. The first approach, device aggregation, makes use of device aggregators as the primary way interface between flexible loads and the utility. So this could be like your vendor cloud platforms making use of APIs to help connect with individual loads and get them managed. The distribution optimization scenario that's in the middle here is really a use case that I think will start to become a stronger one. And I've talked about it on a couple of the projects already. The Seattle City Light EPRI project is a good example where they're trying to show how demand flexibility can avoid having to upgrade their distribution feeder capacity. But in order to do that, that requires what's called a DERMS, or Distributed Energy Resource Management System, to be able to interface and manage at that local utility scale and understand the constraints that are happening at the different nodes in that feeder system. So there needs to be a much more of a handshake, if you will, with the utility in this controls architecture. And then the last category, site optimization, is another version that can happen handshake between the utility and buildings, where we might have something more in the way of like an energy management system or an EMIS that's present, perhaps managing one site, or maybe it's managing multiple. And we do see this as another viable pathway for integrating with the utility. It's worth saying that there's a lot of permutations on how these can all play out, but in general, I think it provides a bit of an overview of the way this architecture could be implemented currently with technologies that currently exists. Underlying all of this, interoperability is key. So in if we're going to manage multiple flexible devices and have them coordinated, we need to understand how much resource each one can provide at a given moment and be able to provide, have a centralized place that can manage and ask for a different amount of load flexibility from different resources. So whether it's a battery versus an HVAC system and so on. And you can see on the left-hand side here, this is sort of like that hierarchy between site level device control, supervisory, aggregated control, and then grid control. And you can understand that there needs to be some level of communication or availability of information across those different layers. So, the workforce of the future will need to be a little more sophisticated with thinking about how do we integrate different control products with these more centralized platforms. And in our work as a national coordinator, we're doing some work to understand the current scalability approaches and understand interoperability means not just being able to communicate once in a certain context, but it means that it's reliable. What happens if the network goes down? That it's portable, that it can survive through changes of building ownership and so on. So there's all these practical aspects to interoperability that we need to think about to make this viable overall. I'm just going to wrap up. This is my last slide with some key learnings so far on the project. So far we have seen several different controls and communication architectures are very viable. We have separate work as the national coordinator to actually research the state of DERMS control platforms. Those are the ones that I mentioned earlier, to understand their readiness to help support behind the meter DER control. Because historically, that's not a model that they operate on. They're much more grid side DERs rather than behind the meter at the building scale. And we'll be developing a common template that can be used by utilities or others to procure different DERMS platforms that will enable this. We also understand there's significant interoperability challenges in integrating these types of load flexible resources and aggregating them. That's going to be a longer conversation, and there's a number of different communication protocols out there that are working on standardizing to make this a much more viable enterprise overall. We also see that depending upon what grid services and what the grid issues are that exist, it may influence the architecture and the approach that gets put forward. So if the utility is really trying to manage and defer capital upgrade due to increased load from electrification in a certain way, that's going to inform the DERMS platform really needs to be in the mix, and the architecture needs to follow from that. So we do see the need overall for multidisciplinary skills, networking, IT, being able to manage API integration is going to be a strong need in this area moving forward. And in general, we're also seeing that there's been a lot of good learning throughout the project cohort over this trajectory as well. That concludes my prepared remarks. I'd be happy to answer any immediate questions if there are any.
So Cindy, I don't see any questions. We are a little bit over time. So
Okay.
I've been waiting to hear about this project for a little while now. So this has been a fantastic overview, and we really appreciate you coming today and presenting.
Oh, of course, anytime. Thanks, Peter. Appreciate it.
Thank you.